Welcome to QuantumGrad. Now it is the 6th episode of our series, and now we are talking about question 6, which is about given this code, wish to insert a code fragment result in the state vector represented by this block sphere. So now we have the code QC is equal to quantum circuit and with the parentheses 1, 1, which means that we have one quantum register and one classical register in the quantum circuit. And now we have to insert the code fragment in the option given below. And the last part is about the implementation of the state vector simulation. Before considering the options, let's focus on the implementation of the state vector simulation. So the first code is that air.get_backend parentheses state vector underscore simulator. What it means is that now we want to have the state vector. So we need to call the state vector underscore simulator from air.get_backend. This is our first code and name it as simulator. And now we want to execute the circuit. So we call execute parentheses QC comma simulator. The third line is that we want to get the result by calling job.result. After that, we want to get the state vector by calling result.get_state vector parentheses QC and name it as output state. Finally, we draw the state vector by calling block_multi-vector parentheses output state. And then we can see that we have the block sphere which is pointing to the direction X. So that is the decided state vector we want. Which one of these 5 options should we choose to get the decided state? Let's get started. As usual, to understand the question, let's get a head study by typing Jupyter Notebook. So now we implement the package. And now let's consider option A. For option A, they give us 2 codes. QC is equal to quantum circuit 1, 1. And then QC.H0, which means that we operate a head gate on the quantum register in the quantum circuit, QC. And now we just call the codes mentioning state vector underscore simulator and then draw the vector, and then we get the results. And the state vector is pointing to X direction. So that is our answer. Next, let's focus on option C. And here we have 2 codes. QC is equal to quantum circuit 1, 1. And then we have QC.RY parentheses math.pi/2, which means that we rotate the state vector by 90 degrees in y-axis. So here is our y-axis, which means that originally it's pointing to state 0 and rotate by 90 degrees, so it's also pointing to X direction. So this is also our answer. So C is correct. So let's get the result. So that's exactly what we want. How about other answers? In option B, we have 2 codes. QC is equal to quantum circuit 1, 1. And then we have QC.RX parentheses math.pi/2, which means that we rotate the state vector by 90 degrees in x-axis. So it is rotating in the x-axis by 90 degrees, which is not our result. How about option D, which states that we should rotate the state by calling QC.RX math.pi/2 and then QC.RZ parentheses -pi/2, which means that firstly we should rotate the state by 90 degrees in x-axis and then we should rotate the state by 90 degrees in z-axis in clockwise direction, and the ultimate direction will be shown as follows, which is not our answer. In option E, we have QC.RY rotating by 180 degrees. So we get it to be in state 1, which is not our answer. So when tackling this question, you should have the concept of block sphere and then draw it mentally or draw it in the whiteboard with the X, Y, Z direction and then rotate the state vector to the desired position as required by the question. And bear in mind that there will be one more correct answer in the question. So you should check all the answers before answering the question. So that's all for my explanation for this question. If you still have any problem, you can comment below. So if you find this episode is very useful, you can share, like it, and comment, and subscribe our channel for our updated notification. And thanks for your support. We are QuantumGrad. Cheers. Ciao. 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 Ciao.